Today we're going to review factoring, and we're only going to factor polynomials that have two terms. And what I mean by that is when you have one term separated by a subtraction or addition sign, and you have another term, and you don't have another subtraction or addition sign. Basically, if you have one subtraction or addition sign. So the steps are, the first step is we're going to look for the greatest common factor, GCF. And we're also going to look for what's called perfect square numbers. Those perfect square numbers are when you take the square root of them and you get perfect numbers. So perfect squares and greatest common factors. So let's look at this very first problem right here. Is there anything common between the x squared and 36? There's no other number here, so there's nothing in common. So that eliminates this one. So now we go to perfect squares. Is the number in front of x squared and 36 perfect? And they are. They're perfect squares. So it meets this qualification. Once you have that, then you must have a subtraction sign. If you don't have a subtraction sign, you can't do anything. So the steps are check for greatest common factor, check for perfect squares, and if it has that, subtraction. In this case, we have all three, so we can then factor this by doing two parentheses, plus, minus, and we take the square root of x squared, which is x, and we put it into both parentheses, and the square root of 36, which is 6, and we put that in parentheses. So this problem right here is factored with perfect squares in this form. Now let's look at this next problem. Two terms, 12 and 18. And is there anything common between the 12 and 18 and the x squared? There is. So we can go ahead and take out that greatest common factor, which in this case is a 6 and an x. That's what's common between both these two terms. So this is called the greatest common factor. And in parentheses, it's what's ever left over by dividing 6x into 12x, which is 2x. And we divide 6x into minus 18, we get minus 3. So the 6x is divided out of these two terms. And what you should be left with is a parentheses that has two terms, and then one greatest common factor. There is no perfect square in this one, so we don't have to do that problem. We have it factored in this format. Okay, now let's look at some other examples. So the first thing we check between this two term is there anything common between the 40a squared and the 32a squared? And in this case, an 8 is common, and so is an a. So this is called our greatest common factor. Then you do parentheses. We divide this into both terms. 8a into 40a squared is 5a. 8a into minus 32 is a minus 4. Now, this problem can't be factored anymore, so this becomes our answer. Now, let's look at our next one right here. In this case, 17 and c is the greatest common factor. So parentheses. And now I divide 17c into 51c cubed is 3c squared. 17c into minus 34c is a minus 2. Now when you have a square inside the parentheses, you need to check to see if it is a perfect square. In this case, 3 is not, so then our answer is complete. Now let's look at this next one right here. Greatest common factor between those two terms is 3, because that's what's common. There's no x in the other term, so I divide 3 into this. When I divide, I get x minus 4. So here's another example where we have a square. Right here, we have a square. Because of that, I need to check if I have perfect squares. And in this case, I do have perfect squares. So this problem continues by dividing or separating it into two more parentheses and taking the square root of x squared plus, minus, and the square root of 4, which is 2. And so this actually factors further because these have a greatest common factor and perfect squares. So you're always checking these two steps. All right, let's look at this last one. Is there anything common between 9x squared and 25? There's nothing. There's nothing common between 9 and 25. So we go to the next part, which is perfect squares. Is 9 a perfect square? Is x squared a perfect square? Is 25 a perfect square? And it is. Once you have perfect squares, you create two parentheses, plus, minus, And now you just take the square root of each term. Square root of 9x squared is 3x, and we put it in the first term. And the square root of 25 is 5, and we put that in the second. So this is the factoring of this using the perfect square method.